I thought I will just kind of summarize what we looked at in as a part of dynamic characteristics in this video. Um, by dynamic characteristics, what we are looking at in this place is basically the behavior of the sensor as the input changes, right? And this would be important, especially when you're going to use a sensor to measure inputs that change, right? You want your sensor to be able to respond to the changing inputs if you're going to do that. And what we said was you could approximate the dynamic response of sensors either by a zero order system, which is essentially the ideal response that we would like to have with sensors, or by a first order or a second order response. Now, of course, there you could have sensors that don't really fit in any of these categories. But usually, what we do is we can approximate the behavior of sensors with one of these three sensor characteristics. Um, we looked at the behavior of sensors to two particular test signals. One was a step input, where the input suddenly changed, and one was a sinusoidal input, where we changed the frequency of the sinusoidal input and looked at the output. However, in other cases, you may want to use other test inputs. For example, you could use a ramp input. A ramp input is an input where the uh, input is increasing with time. Okay. Now you may want that if you want to be measuring a quantity that just keeps increasing with time. Then you want to have a ramp characterization of your sensor so that you know how that sensor behaves for a ramp input. Uh, However, especially with these three kinds of types of sensors, you can do any one characterization, right? You can either do a time domain characterization and give a step input, or you can do a frequency domain characterization and give a sine wave and get the parameters that are associated with each of these systems. So we said the second order system is defined by three parameters: the static sensitivity, the natural frequency, and the damping ratio. So you can evaluate these three parameters from the step characterization by giving a step input and looking at the output. And once you've got the three parameters, then it's a matter of mathematical modeling or putting it into a program to get the ramp input or input to any other kinds of signals. You could do the same thing for the first order system and the zero order system as well. So one of the ways of characterizing the sensors would be to find out what the order of the system is, first, zero, first, or second, and then finding the parameters for the transfer function or the differential equation corresponding to the order of the system, right? And if you get that, then you can kind of predict the output of the sensor for any kind of signal that you have.